Hey there, this is the AP Stats Quideo number 2. We're going to jump right in by answering the basic question. This question is comparing 12 women's lean body mass to their metabolic rate in hopes of finding a relationship between the two. To answer the big question, do heavier people burn more energy? They give us the mass of 12 women here. This is going to be our explanatory variable, and their corresponding metabolic rates, which are going to be our response variable. In order to determine if there is a relationship between these two variables, we're asked to make a scatter plot in our calculator. We do this by pressing Stats Edit, and we then enter in all of our mass data, or our x variable, or our x variables in our L1 list, and all of the rates in our L2 list. After that, we press second stat plot. We turn that on. We make sure we've chosen scatter plots, and we make sure our L1 list is in our L1 data is in our X list, and our L2 data is in our Y list. After this, we press zoom 9, and ta-da, there's our scatter plot. So I have chosen to draw out our scatter plot just so that we can evaluate it more closely. So the next question in the basic question is part B, and the first part of this question asks us about direction. So it's asking a positive direction or a negative direction. We can see that because the lower x values correlate with the lower y values, and the same with the upper x values and the upper y values, that this graph does have a positive direction. The next part of the question asks us about the form, meaning is it linear, is it curved, is it nonlinear? It can be any of those things. As you can see in this graph, besides maybe this point right here, the graph has a linear shape to it. You can draw a line right through here. The last part of the question is asking us about the strength of the relationship. This is going to determine whether or not the researchers were correct in thinking that the metabolic rate is correlated or dependent on the lean body mass. The strength of the relationship can be determined based on how close each point is to that linear line we were just talking about a moment ago. In this graph, you can see that if we were to draw a line right through the data, that each point would either land on the line or very closely to it. This shows that there's a strong relationship between the lean body mass and the metabolic rate, and it confirms the researchers' belief. All right, now we're going to move on to the advanced question of Quideo number 2. The advanced question gives us a table with the age groups of children and their respective median 6-minute walking distances. So the distance in meters that they're able to walk in 6 minutes at these ages. For this problem, we're going to mainly be working with their representative age groups, the midpoint of the age groups, and the median 6-minute walking distances. This is our response variable, this as our explanatory variable. So question A asks us to determine the least squares regression line. The least squares regression line is a line that shows how strong the relationship between the age groups and the walking distances are, and we find this in our calculators by clicking Stats Edit and entering in all of the representative ages in our list 1 and all of the median 6-minute walking distances in our list 2. We then click Stats, Calc, and go all the way down to 8, the linear regression line equation. We click Enter, and it gives us the equation y equals a plus bx. It also gives us our a value and our b value. Our a value is 492.7977, and our b value is 14.7633. Now I've written this out right here just so that we can examine it together. So the final equation is y hat equals 492.7977 plus 14.7633x. And that is our least squares regression line equation. It then asks us to interpret the meaning of its slope. So the slope in this equation is our b value, or 14.7633. And the meaning of the slope in this equation is pretty much that each year the children grow older, they're able to walk 14.7 more meters in 6 minutes. So each year they grow older, they're able to walk this much farther in the 6-minute walking period. Part B asks us to compute the residuals and construct a residual plot. For this, we're going to go back to our calculator, go back to Stats Edit to get to our lists. Now, I already have the residuals here, but I am going to show you how to do it. So we go up to L3, we click Second List, and see Resid here, number 7, click 7, enter, and it will give us all of these data points. Now, in order to graph it, we go to Second Stat Plot, enter. We again make sure that's turned on. We make sure we have our scatter plot chosen. And then the X list is still our L1 variables, but this time our Y list is our L3, or our residuals that we just calculated. So once you're there, you can click Zoom 9, and there it gives you your residual plot. So it then asks us to determine, or pretty much to interpret this graph. So there's not a definite trend between the residuals and the representative age. So there's no curved relationship or linear relationships. It's scattered all over the place, which is good. That means there's no unusual features. Because there's no unusual features, it shows that the ages and median walking distance have a very strong linear relationship. So if this wasn't scattered and it did have a linear trend or a curved look to it, that would mean that the representative ages and the median walking distances weren't very strongly correlated, or they didn't have a very strong relationship. But because it is scattered like this, it shows that the older you get, the farther you'll be able to walk in 6-minute increments.